Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing Section 2.2, the multiplication property of equality. In this section, we will use the multiplication property of equality to solve equations. We will solve equations in the form negative x equals c, and we will use the addition and multiplication properties of equality to solve equations. Let's get started. Let's get started with a definition. And here we're defining the multiplication property of equality. The same non-zero real number or algebraic expression may multiply both sides of an equation without changing the solution. And symbolically, we write if A is equal to B and C is not equal to 0, then A times C is equal to B times C. So in other words, we can multiply both sides of an equation by the same number as long as it's not 0, and it does not impact the solution of the equation. Let's try an example. Example 1. We want to solve the equation. And we have x over 3 is equal to 12. So x divided by 3 is equal to 12. How do we solve this equation for x? Well, we have x over 3, which is the same as 1/3 x. And what we want to do is we want to get rid of the division by 3 by doing the opposite operation. Well, the opposite of division is multiplication, so we can multiply both sides of our equation by 3. On the left-hand side, we have 3 divided by 3. So those will cancel, and we're left with x is equal to 12 times 3, and 12 times 3 is 36. So our solution is x equals 36. Let's try another example. Example 2. Again, we want to solve the equation. And in our first case, we have 4 times x is equal to 84. Again, remember, as I'm reading that, 4 times x equals 84. Think about what undoes that 4 times x to get x by itself. What we need to do is we need to divide instead of multiply, and we divide both sides by 4. Well, that cancels the 4's out on the left-hand side, and 84 divided by 4 is 21. So our solution is x equals 21. Part B, we have negative 11 times y is equal to 44. How do we undo that negative 11 times y? Well, we divide both sides of the equation by negative 11. The negative 11's cancel on the left-hand side, so we're left with y equals 44 divided by negative 11, and 44 divided by negative 11 is negative 4. So that's what happens when we divide out by a negative number. Well, what happens if we have a fractional coefficient in front of our variable? Let's try that in example 3. Example 3. Again, we want to solve the equation. And we have 2/3 y is equal to 16. Well, we have 2/3 times y is equal to 16, so we can just divide both sides by 2/3. And sometimes you'll see this done, and we can do that math there. The 2/3 will cancel on the left, and we're left with y equals 16 over 1 divided by 2/3. Well, if you remember back to dividing fractions is as easy as pi. We can flip the second fraction and then multiply. So we'll have 16 times 3 halves. We can simplify or reduce the 16 to 8 and the 2 to 1 because they have a factor of 2 in common. So we end up with 8 times 3, which is 24 over 1. So y is equal to 24. Now, is there another way we could have solved that? Yes, there is. We could have started by multiplying both sides of the equation by 3 and then dividing both sides of the equation by 2. Let's do a second part to number 3. We'll call that part A. Part B, we have 28 is equal to negative 7 over 4x. So this time we're going to do it the other way, where we first get rid of the denominator. And the way we get rid of that is by multiplying both sides of our equation by 4. So the 4's will cancel on the right-hand side, and we get 4 times 28, which is 112, and that will equal negative 7x. And then we can divide by negative 7 on both sides to get rid of the negative 7 with x. The negative 7's cancel, and we get x is equal to 112 divided by negative 7, which is negative 16. Well, what would happen if I had a negative 1 coefficient in front of x? Let's try that in example 4. Example 4. Our instructions are still the same. We want to solve. For part A, we have negative x is equal to 5. Okay, what we need to understand is that anytime we see a negative in front of a variable like this, we're assuming that the coefficient here is negative 1. So anytime you see a negative x or a negative y, that's the same thing as negative 1 times x. And then in this case, it's equal to 5. So the way we get rid of that multiplication by negative 1 is we divide both sides by negative 1. The negative 1's on the left-hand side cancel, and we get x is equal to 5 divided by negative 1, which is negative 5. So that's our solution. Okay, part B, negative x equals negative 3. Same story. You see the negative in front of x. Remember that that's negative 1 times x. Divide both sides by negative 1, and you get x is equal to negative 3 divided by negative 1, which is just 3. So that's what you do when you have a negative in front of your variable as the coefficient. Okay, now let's combine using both the addition property of equality and the multiplication property of equality in an example. Example 5. In this example, we want to solve the equation 4x plus 3 equals 27 for x. Okay, so it's 4 times x plus 3 equal to 27. So to get x by itself and to isolate it, we need to undo the multiplication and the addition on the left-hand side. And we sort of go in the reverse order that we would do order of operations. And so we'll start with the addition or subtraction first. And we'll start by subtracting 3 from both sides. 4x plus 3 minus 3 is 4x. 27 minus 3 is 24. Now on the left-hand side, we have 4 times x. The way we undo multiplication is through division. So we'll divide both sides by our coefficient, which is 4. On both sides, the 4's cancel on the left-hand side, and we're left with x is equal to 24 divided by 4, which is 6. Okay, let's try another example. Example 6. In this example, we want to solve negative 4y minus 15 equals 25. Again, we're going to start with the addition and subtraction. So we need to get the constant negative 15 to the other side. And the way we do that is to use the opposite operation of subtraction, which is addition. So we'll add 15 to both sides. And on the left-hand side, the 15 and negative 15 cancel out. So I'm left with negative 4y is equal to 25 plus 15, which is 40. Then we have negative 4 times y is equal to 40. To undo that negative 4 times y, we divide by negative 4. The negative 4's on the left-hand side cancel. And you get y is equal to 40 divided by negative 4, which is negative 10. Okay, and one last example, we'll do example 7, which we will want to solve 2x minus 15 equal to negative 4x plus 21. Notice in this case, this is a little bit different kind of an example than we've seen before. In this case, we have the variable on both sides of the equality symbol, and we have a constant on both sides. So how do you decide which side you want x to be on? Well, if I get the choice, I look and I see a 2x and a negative 4x. I want to get the negative one typically and move it over here so I don't have to divide by a negative. That's my typical practice. You don't have to do it that way. You can move it to either side as long as you do the same thing to both sides of the equation. So what I'll do first is I'm going to add 15 to both sides, all thinking in mind that I'm going to move the x's from the right side to the left. So we'll move the constants to the right. So when I add 15 to both sides, I get 2x is equal to negative 4x plus 21 plus 15. 21 plus 15 is 36. Now I can add 4x to both sides. The negative 4x and the plus 4x on the right will cancel, and I'm left with 36. The 2x plus 4x is 6x. Now I have 6 times x. To undo that multiplication, I divide both sides by 6. The 6's will cancel on the left-hand side, and I'm left with x is equal to 36 divided by 6, which is 6. Okay? And that is the last example of section 2.2, the multiplication property of equality. Good luck on your homework. Please let me know if you have any questions as you go through it, and I will see you in the next one.